All right, so I stopped the recording, but 10 had a part 2. This time we're going to do G composed of F, and then find the domain of that. So just showing that there's a difference between F of G and then G of F. This 10B. So we want to do G composed of F this time, which means we're going to start with G being our outer function, and then we're going to plug in the F equation into G. So the G equation is x minus 2 over 2, so leave a blank space for x minus 2 divided by 2, and in the place of x we're going to replace it with the F equation, and the F equation is the square root of x minus 4. So we have the square root of x minus 4 minus 2 divided by 2. And you can't just divide those 2's out. It has to be a 2 come from both of them to do that. So this is our G of F equation. Okay, is this. Okay, and now let's talk about domains. So from the previous problem, domain of F. So this time we get to see what I was trying to mention. Domain of F was this guy. Domain of F was 4 to infinity. Okay. Domain of G was negative infinity to infinity from the previous part. So whenever I use the G equation, you could use everything. However, whenever I plug in F to this, now my restriction is, since I could not use anything less than 4 here, because it would make it negative, I still can't use it with this equation. So my domain starts here. This is where my domain starts, and it's kind of like the overlap. Your domain starts there, and then you remove any restrictions. But I don't want to say the overlap because last time it changed quite a bit. So you start with the one that you plugged in. So our domain is starting from 4 to infinity. And then from here, we're going to find the domain. So with this one, we have a fraction, but there's no x's in the bottom. So no restrictions there. We have a square root. If I solve this and find out what makes this 0 or negative, it's the same thing, 4 to infinity, because that's the same exact square root. Nothing changed. The outside doesn't matter, only what's under the square root. So we don't get any new restrictive values there, and we don't have any logarithms. So our domain of G of F is the same as the domain of F, okay, which is from 4 to infinity. And then our function, square root x minus 4, get out, minus 2, all divided by 2. All right, number 11, we want to decompose the function. So we have f, we're given f, and we want to find g and h so that f of x is equal to g of x composed of h of x. So their notation is a little bit different. Normally they say f composed of g is equal to h of x, but they're just kind of switching the letters around. So the outer function, I want it to be g, and then the inner function, I want it to be h of x. So the simplest way, and there's more than one way to do it. Let me see if I can figure out a couple of different ways we can make this one work. It's going to be a couple ways I can make this work. So let's say that g of x, this is just a simple way, g of x is going to be the outer function. So g of x is going to be the cube root of, we're going to say, just x. We're going to replace all that with x. Cube root of x, and then the minus 3. And then if we let h of x equal everything that was under there, the inner function, so that would be negative x squared plus 3. Then whenever I plug this in for x, okay, you will get the original function. We could also say that g of x, and it just takes time, like practicing with these, and you'll begin to see it a little bit later. We can also say that this is the cube root of just x plus 3 minus 3, and we can say that h of x is equal to, it'll be a negative x squared. So all you got to do is replace x with this, and then you get the original. And then we could also, after looking at this, we could also just replace this whole thing with x. We could also say that g of x is equal to x minus 3. And then we could say that h of x is equal to cube root of negative x squared plus 3. So you replace this whole thing with x, and then you get the same equation. So this is just 3 different ways, but there are probably many, many, many more that you could do and make this work by adding and subtracting constants. It doesn't really matter. But the main idea is just to be able to rewrite it, and this is the first way. I would just simply replace anything inside of a grouping symbol with x, and then let that be my basic function, and then let what was inside the grouping symbol be my other function. And if you look at each one of these, if you replace the x with all of this, you're going to end up with f of x, or the original function, which is the cube root of negative x squared plus 3, and then a minus 3. Because if you replace this here, you end up with that. If you replace this here, you still end up with that. And also if you replace this here, you still end up with that. So that's 3 different ways. And this is what we mentioned in the textbook earlier, that there's more than one way to do it. There's not just one. So I'm just going to go with the first option. That's the simplest way to do it. But any of these should work. So I'm going to go cube root of x, and then minus 3. And this guy, we're going to let it be negative x squared plus 3. And then 12, we have one more decomposition. We're going to do the same thing. So look, we have a fraction bar. So this is kind of like my grouping symbol here. So my outer function, g of x, the first, I'm just going to let it be equal to 4 over x. Just replace everything. 4 over x. And then that means h of x, my other function, is going to be everything else that I got rid of, which was the negative 2x plus 5. That's the most simple way of doing that. Okay? And that's the way I would recommend. And then as you spend more time, you can do more complicated things. 4 over x, and then negative 2x plus 5.